Good morning, students. Now, today, shall we go to next topic for revision? Shall we go to chapter 3 for revision? Okay, right. Now, we will go to coordinate geometry. Okay. Suppose there is a plane. This is called Cartesian plane. So, this is named after famous mathematician Rene Descartes. So, on his name it is called Cartesian plane. So, this plane is used for to locate a point. To locate a point in a plane, we need its horizontal and vertical position as location. Okay, so I took a point here. How to identify that location? Like mapping in geography, like that. So we take its horizontal position and vertical position and its horizontal position. Okay, take this units as this is 1, this is 2, this is 3, and here also 1, 2, and this is 3. So this is distance, vertical distance is y is equal to 3, here x is equal to 3. This horizontal distance is called abscissa, and this is called ordinate. So ordinate is what is called ordinate is the perpendicular distance from the point to x-axis, right, as y. Similarly, abscissa is, so both x and y together give the location of the point. Yes. So the point here A, the point C3, 3 is the location of it in the coordinate plane. What is the other name for coordinate plane or Cartesian plane? X is equal to 3, y is equal to 3. So abscissa and ordinate. So ordinate is the perpendicular distance from the point to x-axis as y. Abscissa, the perpendicular distance from the point to y-axis as x. So this x is equal to 3, y is equal to 3. And you are getting, so from the figure, quadrilateral O, this is O, OACB is a rectangle, right or not? As CA is perpendicular to OA and CB is perpendicular to OB. Okay, so this system is called, okay, so this system is called Cartesian rectangular coordinate system, because every point will form a rectangle. So this is called a Cartesian rectangular coordinate system. Are you clear now? So location of a point in a plane is determined uniquely by its perpendicular lines to x-axis and y-axis. The perpendicular to x-axis is called the ordinate and perpendicular to y-axis is called the abscissa. Now you can have this, your many examples are there. Yes, you can have located this for your desk or your lamp in your place at your home or your house in the different buildings and areas and roles. Likewise, the location of a point or an object in a plane is determined uniquely by this coordinate system, which is devised by the famous mathematician René Descartes. So it was named as Cartesian coordinate system on his name. So the perpendicular to point to the x-axis is called the y or ordinate, and perpendicular to the point to the x-axis is called the x as abscissa. Are you clear? So the combination of x and y is the standard point form. So first abscissa, then you have to write ordinate always. Are you clear? So x value, this value, x and y is indicates x value is odd abscissa perpendicular from point to the y-axis, and y value indicates ordinate from perpendicular from point to the x-axis. Are you clear? So you are clear with this part? What is the introduction of coordinate geometry? Yes, all of you are clear? Good. Next. Do you want to note down or can I erase? Are you noting or can I go? Can I rub this one? Can I rub this one? Okay. Can I wipe it out? Okay. Next. Now, there are two axes, you know. In a Cartesian plane, there are two axes. One is the horizontal axis and the other one is vertical axis. Vertical axis. So the names are also indicated as x-axis and y-axis. Right? So when they are intersecting automatically, they are forming. So four quadrants are formed with the intersection of x-axis and y-axis. So this is origin as origin intersection point. Zero, zero. X dash, y dash. So Q1, Q2, Q3 in anti-clockwise direction. Okay. Now in this case, here x is positive x-axis. Like 1, 2, 3, 4, 5 you take. This is negative y-axis. This is negative x-axis. And this is positive x-axis. Okay. This is, so this case is x positive and y positive in this case. Here x negative and y positive. So x negative, y positive. And in this x negative and y also negative. And in this x positive and y negative. So always your standard point location is what? So since the point xy is the location in any position in Q1 plus x plus y, Q2 minus x plus y, and in Q3 minus x minus y, and in Q4 it will be x comma minus y. This is the position of the points. Okay, so what is the note? We'll go note. The sign of x and y indicates the location of the point lies in respective quadrant. So depending upon the sign of x and y, you will be locating the position of x and y quadrant. Are you clear? Yes. This is all about the location of the point and introduction. This much only we are having today, but we'll have some problems or applications of numericals to have this practice. Note down. Okay, right? Next question. Now, note. Can I write this one? Yes? Can I write this part? Suppose here 1, 2, 3, 4, 5. So what is this position of the point? A, B, C. So if the point lies on x-axis, its y-coordinate is 0. Therefore, the general form is of a point lying on x-axis as x comma 0. And here it will be suppose -1, -2, -3, -4. So here it will be suppose D -1 comma 0. Okay, here 1 comma 0 like that. Right? X is an integer, positive or negative. Okay? Are you clear? Because on y-axis, on x-axis, y value is 0. So standard form is x comma 0. Suppose you take in y-axis, point lying on y-axis. Here positive side, 1, 2, 3, 4, 5. So this is x, this point is 0, 2. Here 0, minus 1, 0, minus 2, like that will come. Okay, this is minus 2, this is minus 1. Similarly, if the point lies on y-axis, its x coordinate is 0. As the general form of a point is zero comma y. Y is an integer. Now suppose the point is here, suppose P. So this is x comma y, because you have something here and something here. So if the point lies in any of the quadrants, then its location wise, the form is Px comma y. Okay, because it lies on any part, so it will be x comma y. X value will be there, y value will be there. If on x-axis y is 0, on y-axis x is equal to 0. So what is that we have decided? On x-axis y is equal to 0, on y-axis x is equal to 0. Okay, clear? Okay, noted? Yes. Next. So if we know the point, we can tell the location or quadrant. Also, if we know the location or quadrant, we can tell the point and its general form. So for example, if we know the point lying on, P lies on Q1, then P is equal to x comma y plus x comma plus y, right or not? Suppose if P is equal to, if Q is equal to minus 2 comma 3, so x negative, y positive. So Q lies in quadrant 2. Like that we can say or not? So location gives the quadrant gives the general form of the point. Are you clear? Yes? Yes? Next. So to locate the point first, what you have to go? You have to go with x-axis, then you have to go with respect to always the location of the point gives the direction from origin first to x-axis and then to y-axis. Okay, so suppose always how to look at the point. Okay, so take the first the coordinate plane, divide it into x dash, x, y, y dash. Okay, likewise. So I want to find P minus 3 minus 4. Both are negative. So dice in the third quadrant, clearly, right? So Q3, that you know. So first origin you start. Origin to minus 3, x-axis wise you go, minus 3. And from there come to minus 4. Minus 4 means downsides, like this. So this is Q or P minus 3 minus 4. Understood now? Like this you have to locate. But you have to divide all this plane, location all with respect to graphical plane you have to do. Already squared and the grids are there. And then you have to use the pencil. So this is minus 3 and minus 4. Are you clear? So this length is minus 4 and this length is minus 3. Are you clear? Similarly, so Q minus 3 minus 4 we have located. It lies in the Q3 P. Then again you can go for Q minus 2 comma 5. So from 0 to minus 2 come here. 5 is passwords upward. So go to here. This is minus 2 5. This is Q. Right? Q2. 2 comma 3. This is R. So x come to 2. First point to 2. 2 means point 1 enough. Come this side. And then you go 3 side. This is R 2 comma 3. So this is 2 and this is 3. This is Q1. Yes. 4 comma minus 2. So go to 4 first here, 0, 1, 2, 3, 4 and minus 2, come down. 4 comma minus 2, this is yes. So this point is, yes, this is in Q4. So are you clear how to look at the point and general form also of it? Yes? Good. So like this you have to locate the points and its general location also. Are you clear all of you? So you understood how to locate a point on the plane and you understood Yes? Okay. Now, one more note. In the point, in the Cartesian point or in the coordinate point, if x is equal to y, then it is square. If x is not equal to y, then it is rectangle. But every square is a rectangle. So it is called rectangular coordinate system, Cartesian. See here, if x is equal to y, it is a square, 2 comma 2 suppose, or 1 comma 1. If I take 1 comma 1, so this is a square, you know it, right? This is a square. But x is not equal to y, it is a rectangle like this all. But every square is a rectangle. So it is generally named as rectangular coordinate system. Are you clear now? Yes, why it is named? Okay, understand all of you? I think this is only theoretical topic only. You have much. There won't be much doubts for your part. So tomorrow we'll go to next part. Okay. Thank you all. We'll continue tomorrow. Right.